In this video, I will be going over the section 12.1 notes, which is all about trigonometry and the 6 different trig functions. Trigonometry is the study of relationships among the angles and sides in a right triangle. And so trigonometry itself is the study of right triangles. And so today we're going to go over 6 different trig functions that are going to be comparing the side lengths of a right triangle using different ratios. And so all of those 6 trig functions are listed here at the top. The first one is the sine function, followed by the cosine function, followed by the tangent function. Then this is cosecant, secant, and cotangent. So these are all abbreviations. They use 3-letter abbreviations for these 6 different trig functions, and they each have their own definition, which is provided on your notes. The sine function relates the opposite side from your angle to the hypotenuse of the right triangle. So before I go through that specific definition and the rest of them here, it's really important to talk about this component right here. Sine, cosine, tangent, cosecant, secant, cotangent are all operators on an angle. And the angle that we're referencing in this right triangle is called theta. Theta is a Greek letter. This is capital theta. And in order to talk about a trig function, you have to talk about an angle of a right triangle. And so if I say I want the sine of theta, if I want the sine of this angle, I want to take the side that is opposite of theta and divide it by the hypotenuse of the right triangle. The cosine of theta, the cosine of that same angle, is something different. That takes the adjacent side, so the one next to theta, and then divides it by the hypotenuse. And you can kind of see that tangent is just the opposite side of theta divided by the adjacent side. Cosecant, secant, and cotangent are all reciprocals of the ratios right above them. So if I were to take, and it's listed right here, if I were to take 1 divided by sine of theta, which is 1 divided by, I'm going to abbreviate, the opposite divided by the hypotenuse. When you take a reciprocal of a fraction, it will basically flip it, and this will become hypotenuse over opposite, which is the exact definition that you have here, where it says cosecant of theta. So all of these reciprocals have already been taken care of in their definitions. Just kind of be aware that cosecant is 1 over sine of theta. The secant is 1 over cosine of theta, and the cotangent is 1 over tangent of theta. That one's easy to remember. Cotangent and tangent go together, but the other two are a little bit different. Secant goes with cosine, and then cosecant goes with sine. You would think it might be the other way around, but it's not. So just kind of be aware that for this first section in our trig unit, because we're going to go through quite a few sections in this chapter, we need to know the basic definitions of these 6 functions and then be able to answer questions based off of them. The other thing that you need to remember from geometry class is the Pythagorean theorem, and that's something that only works for right triangles. And with this being a unit that is over the relationships found in a right triangle, this is going to show up quite a bit. So let's go ahead and jump into some examples here. Eventually we'll come back and talk a little bit more about these functions, but for today let's just do the definitions. So it says in example number 1, use the diagram to evaluate the 6 trig functions of angle theta. Okay, so I have my theta right here. I have then, if this is theta, this side right here is going to be opposite because it's across from theta, the 5 being right next to it, so it's adjacent. And the other important part to note that the hypotenuse is always across from the right angle, and the hypotenuse is always the longest side of a right triangle. So when we say the adjacent side, we're talking about one of the legs of the right triangle. You never treat the hypotenuse as adjacent. So we have the opposite leg, the adjacent leg, and then the hypotenuse never really changes in terms of the fact that it is always the longest side and it is always across from that right angle. Now the problem with evaluating these 6 functions, I actually need to find the hypotenuse first, and that's where Pythagorean theorem comes into play. Pythagorean theorem is a squared plus b squared equals c squared, and that's just leg squared plus leg squared equals hypotenuse squared. And you might remember this a little bit from geometry, but there are certain numbers that work really well with the Pythagorean theorem, and those are called Pythagorean triples. This is going to be one of those. I believe the answer comes out to be 13, because when you take the square root of 169, you get 13. All right, so now sine, we know, is opposite over hypotenuse, so that's 12 over 13. So then cosecant will just be the reciprocal of that, which is 13 over 12. Okay, so if you remember that relationship, those two you can answer at the same time. Cosine of theta is adjacent over hypotenuse, so 5 over 13. So then the secant of that same angle is 13 over 5. Note that it has to be the same angle. If they were to maybe reference this angle right here in a different question, then I would have to change my opposite side and my adjacent side. So opposite and adjacent are relative to the angle that you're looking at. So if they switch up to a different angle, then you're going to have to switch the way that you think about your diagram. Tangent is going to be opposite over adjacent, so that is 12 over 5. So then that will make the cotangent the reciprocal, which is 5 over 12. So once again, just kind of be aware that opposite and adjacent are talking about legs, and opposite and adjacent can change. So if you use this triangle for one problem, and then they ask you about a different angle in that same triangle, then your opposite and adjacent may switch. It just depends on the problem. Number 2, it says let theta be an acute angle of a right triangle. Okay. Here's my right triangle, and here's theta. Find the values of the remaining 5 trig functions, and they give us the tangent as 7 over 3. So what's really important to note is I should label my diagram. This is hypotenuse. That one's pretty easy. Opposite is actually going to be over here because I've put theta kind of in this bottom corner, so I go across. So this one's opposite, which would leave this one as adjacent. They give me tangent as 7/3. Tangent, we know, is opposite over adjacent. So I have the 7 and I have the 3. So I'll do Pythagorean theorem real fast to find the hypotenuse. Then I can go through and find those trig functions. And actually, I'll just do Pythagorean theorem over here. Seems like I have more room. So this would be 3 squared plus 7 squared equals c squared. That is 9 plus 49, which is 58. 58 is definitely not a perfect square, and I don't think 58 can be broken down using perfect squares. So I'm going to leave it as the square root of 58. All right, so sine is opposite over hypotenuse. Now, that is going to need cleaned up because there is a root in the denominator, but before I go ahead and clean that up, I'm going to go ahead and write down the reciprocal of that answer for the cosecant. Okay. Cosine, we know, is adjacent over hypotenuse. Once again, that's going to need cleaned up, but I'll wait on that because I want to write down the secant, which is just the reciprocal of that answer. And then cotangent is the reciprocal of tangent, so that one is just 3/7. So then all I have left to do is just to clean up the sine and the cosine, which it's the same process for both ones. You just get a different answer. So this one for the sine should be 7 times the square root of 58 over 58. And this one's going to be 3 times the square root of 58 over 58. And there we have it. Those, given one function, those are the rest. And so the hint here is a very good suggestion, drawing a picture, labeling the picture. And so your picture might look different than someone sitting next to you, maybe if you were doing this in a math class, because someone could draw theta up here, 3 and 7 would switch spots, but then so would the opposite and the adjacent notation. So it's all relative to the angle. And that's the key to these problems, understanding the relationship between that angle and the sides of the right triangle. Let's do a few more problems here on the next page. It says for number 3, find the value of x, round to the nearest tenth. Here's one major application of the trig functions. You know, why are we taking the time to study trigonometry? Why look at these 6 different definitions? Well, if I look at problem number 3, I want to find a side of the right triangle. I want to find the length of this leg of this right triangle. And unfortunately, I can't use Pythagorean theorem because I am missing too much information. All right, so this is something that I used to teach in my other geometry class, but it's really important to note that if I could use Pythagorean theorem, that would probably be the way to go. But I don't know the hypotenuse, nor do I know this leg, so I just don't have enough information to use Pythagorean theorem. Instead, I'm going to use trig to answer this question, because now I'm going to relate this angle that they gave me to these sides. Let me go ahead and label my triangle. If I'm going to use 63 as my angle of reference, then this is going to be opposite. And then this side is also a leg, so this is going to be adjacent. So then you just figure out which trig function could I use. There's a couple different ones that you could use here, but if I stick with sine, cosine, or tangent, which one would be opposite over adjacent? And so that's going to be the tangent. So I'd say tangent of the angle. So instead of writing theta, I would actually put in 63 degrees equals, and now I write my ratio, it's opposite over adjacent. So at this point, you would need to use a calculator to estimate the value of the tangent of 63 degrees. So your calculator is programmed with all of these different values. You could also use a table of values, though your calculator is a better bet. If I take the tangent, and here it is right here, of 63 degrees, I get around 1.9626, and then to solve for x, I would multiply both sides by 2. So then we are going to get around, and I'm using more decimal places in my work, but I will round my final answer at 3.9. So that side is roughly 3.9, and the important part about your calculator, when I type in the tangent of 63, 1.9626, that number is the decimal version of this ratio. So those ratios are going to be constant every time you have a 63-degree angle and you take the tangent of it. So basically, I'm just using a ratio to figure out what's missing. Knowing the constant, missing one part of the ratio, it's not so bad to solve for x. So let's do that again. Number 4, you can see here that I have to find the angle this time. So while I can use Pythagorean theorem doesn't give me the angle. Pythagorean theorem would just give me this hypotenuse here. So I definitely can't use Pythagorean theorem to help me out. So now what I'm going to think about is the angle. This is opposite for the 15. 2 would be adjacent. So it looks like we're going to use tangent again. But look at the way that I write this. So the problem here is I can't type in the tangent of x into my calculator. X is a variable. I don't know what the angle is. And since I don't know the angle, I can't necessarily find something that will help me out for the calculator. So you're going to do something different. You're going to get rid of the tangent on both sides, right? I'm trying to solve for x. So in order to isolate that x, to remove the tangent, you're going to use the inverse of tangent, which is this notation right here. The inverse of tangent will be done on both sides. And when you take the inverse of tangent, it is going to cancel with the tangent just to leave that angle. And now I want the inverse of 15 over 2. And so the way that you type this into your calculator is you hit second, and then you hit tangent, so that brings up the inverse, and then type 15 divided by 2. This will reverse the process for you, so that way it can take this ratio, it can take 15 over 2, and then see what angle it corresponds to since you're telling it to use tangent. If you were to use cosine or sine in this particular problem, then you would get a different answer because those are different ratios and different operators. By the way, that's around an 82.4 degree angle. So this is the first video for this section. A couple more to go, basically for the chapter. But we'll stop there. Let me know if you have any questions or concerns.